Welcome back to The Explainer. Today, we're unpacking a concept that's literally shifting the ground beneath our feet in the world of artificial intelligence. Okay, let's dive right into this, the Codatta methodology, and the fascinating journey of taking foundational AI and transforming it into highly specialized systems. Now, if you follow this space, you already know we have these massive, incredibly capable base models. But, there's a huge gap between an AI being capable of writing a catchy poem and being capable of accurately diagnosing a rare disease, engineering a bridge, or parsing a dense legal contract. Making that specific leap? That's exactly what we're exploring right now. So, that brings us to a huge question. How exactly does a general AI actually become specialized? Well, it kind of helps to think of a foundational model as this brilliant, eager intern. They've just read every single book in the world's largest library, but they have absolutely zero real-world job experience, right? They know all the words, they get the syntax, but they don't know your specific industry's workflow. They don't know the unwritten rules of the trade or the really deep nuances of your specialty. So our central challenge today is figuring out how to take that powerful, broad model and forge it into a sharp, reliable specialist, one you can actually trust in a high-stakes environment. All right, let's move to section 1 and see how this builds. General versus specialized AI, going from foundational to expert. So here we're looking at the two extreme ends of the spectrum. On one side, we have foundational AI. This is your raw ingredient. It's broad, it's a generalist, it's absolutely fantastic at predicting the next word in a sentence based on patterns, but it really lacks that deep, grounded context for specific professional tasks. Then, on the exact opposite end, we've got specialized AI. This is your sharp, precise expert. It doesn't just guess based on probability, it knows, based on absolute domain accuracy. Now, to get from the left side over to the right side, we need a bridge. We need some sort of catalyst to trigger this evolution from novice to master.
Which brings us to section 2, the transformation equation, knowledge times data. So the crucial point is this deceptively simple multiplier, knowledge times data. Notice it's not just data plus more data. For years, the whole AI narrative was literally just feed the machine more data. But as we know, raw data is just noise without structure. The real magic, the actual transformation, happens when you multiply that data by human knowledge. And that right there is the foundational concept of the Codatta approach. You aren't just dumping a bunch of raw documents into a server, you're actively applying structured human expertise to make that data actually meaningful and actionable for the AI.
The core philosophy here is that domain knowledge turns general models into specialists by teaching, guiding, grounding, and testing. This perfectly unpacks why data alone just falls flat. Think about it. You need actual doctors to train medical AI, lawyers to train legal AI, and software engineers to train coding AI. It requires the active, hands-on application of human expertise to forge a true expert system. The human essentially takes on 4 distinct roles here: the teacher, providing the lesson, the guide, pointing the way, the anchor, grounding the facts, and finally, the ultimate test grader, verifying the work. Let's jump into section 3, the 4 training pillars: teaching and guiding. So, how do we actually execute this whole thing? Well, pillar number 1 is fine-tuning. This is where we really get under the hood of the AI. Fine-tuning involves feeding the model highly specific domain examples, complex reasoning paths, and, honestly, most importantly, edge cases. An edge case is that weird, highly specific one-in-a-million scenario that would completely trip up a novice, but is easily handled by a pro who's seen it all before. By feeding the AI these edge cases, we're literally shaping its internal logic. We're fundamentally rewiring it so it stops thinking like a broad generalist and actually starts reasoning like a seasoned professional. Next up, we have RAG, or Retrieval-Augmented Generation. Now, what's really interesting about this slide is that this particular process happens entirely at runtime. While fine-tuning changes the model's brain ahead of time, RAG acts more like an open book test while the model is actually in the middle of answering your question. It curates trusted sources and verified facts, pulling them in right at the exact moment of generation. This is huge because it ensures the AI's output is firmly anchored in reliable, human-validated knowledge. So instead of the AI trying to vaguely remember a fact from its massive pre-training data, which, let's face it, sometimes leads to it making things up, it actively retrieves the precise, correct info to formulate its answer. Our third pillar is prompting. Now, you might just think of a prompt as typing a quick question into a chat box, but at this architectural level, it is a precise science. Prompting here means designing inputs that reflect actual expert thinking, intricate logic chains, and highly specific task framing. It's all about asking the question in a way that forces the AI down a very specific analytical path. The brilliance of this pillar is that it guides the model to expert-level performance, completely bypassing the need to retrain the whole system. You literally just have to know how to speak its language exactly like an expert would.
And the final pillar, the one that ties the whole shebang together, is evaluation. This is where we rigorously put the system to the test. Evaluation is all about providing crucial feedback. But here's the kicker. It relies entirely on human domain judgment. I mean, you can't just have some automated script pop up and say, yep, this 50-page complex legal brief looks good. No way. You need a human expert to step in and assess its real-world readiness. Human domain judgment is absolutely critical to look at the AI's output, catch those subtle little flaws, and feed that critical feedback right back into the loop to continuously improve the system.
And this brilliantly illustrates how these 4 pillars work together as one complete transformation system. Just to recap, fine-tuning permanently shapes that internal logic. RAG steps in to provide runtime grounding with real verified facts. Prompting steers the AI through expert logic chains on the fly, and evaluation, that acts as the ultimate real-world assessment. It's a complete interlocking toolkit that leaves absolutely nothing to chance. All right, moving into Section 4, Real-World AI Readiness, Assessing AI. So once we've successfully applied these 4 pillars, it's all about putting the AI to work where it actually counts. The most crucial domains for this level of rigorous evaluation are things like research, planning, and scientific domains. These are incredibly high-stakes areas, right? Think about it. If a generic AI makes a mistake while writing a fictional short story, it's kind of funny. But if an AI makes a miscalculation in complex scientific research or large-scale strategic planning, the consequences are massive. In these specialized fields, precision is quite literally everything, and it is strictly human domain judgment that determines if the AI has truly graduated from being a generalist to a true expert, ready to be deployed out into the wild. Which leaves us with this final, pretty vital thought to ponder. As AI tackles increasingly complex scientific and planning tasks, who is actually going to provide the ultimate domain judgment to keep it grounded? We've clearly seen today that simply throwing more data at the problem is absolutely not the answer. It requires that human element, the expert actively acting as the teacher, the evaluator, the grounder. The future of expert AI systems isn't just about building bigger computers or faster algorithms. It's about how effectively we can transfer human wisdom and deep domain knowledge directly into those systems. So think about the unique domain knowledge you possess right now. Consider how your specific expertise might just be the exact key needed to train the next great specialized AI in your field. Thanks so much for joining me on this explainer. I hope it brought some real clarity to how this incredible technology is evolving, and I'll catch you next time.